For the function j of x as x plus 5 over x squared plus x 6x plus 5. What's the domain? Yep. So if x squared plus 6x plus 5 were set equal to 0, this factors as x plus 1, x plus 5. So slow. So x cannot equal -1 or -5. Again, writing it like this is totally fine. If you want to use interval notation because you're fancy, go right ahead. You don't have to. If you would, take a second to find your x and y intercepts. So remember, for a fraction, you have x-intercepts when the numerator equals 0. Because a fraction equals 0 when the numerator equals 0. So what number of x would you need for to have an x-intercept? -5, but so do you have x-intercepts? No, -5 is not in your domain. It has to be in the domain to be an x-intercept. No x-intercepts. But yes, as you just said, we found a number that made the denominator 0, -5, and the numerator 0, -5. So that's going to turn into what for the graph? A whole. So we already know something about part C. Y-intercept, put in 0 in for x. Since 0 is in the domain, we will have a y-intercept. What does the numerator give you? Denominator? 5 over 5 as an ordered pair. Vertical asymptotes and holes, take your numbers that aren't in your domain, -1 and -5, stick them into the numerator. Well, we should already know what's going to go on here. Because if we stick in -1, are we going to get 0? Nope. Oh, I didn't mean to do that. I meant to do this. Goodbye. No, I said goodbye. -1 plus 5 does not equal 0. So what happens at x equals -1? Good job. You put the numbers not in the domain into the numerator. Because the step 1 is really find the numbers that make the denominator 0. Well, that's basically your domain. Your number's not in the domain, I should say. If you don't get 0, you say vertical asymptote. If you do get 0, nice segue there. If we plug in -5, what do we get? 0, which means that the whole correct. All right, so we got a whole. So how would this factor? I'll do the numerator. Yep, x plus 5, x plus 1. Notice we already did that in part A, so this shouldn't be too bad. What cancels here? So what are you left with? One over x plus 1. Biggest mistake is students do not write that 1 in the numerator. So the reduced form is just like the original fraction, except on the calculator, because the calculator doesn't graph holes. So the original function has a hole, this one doesn't. So again, for your purists out there, you would have to say x does not equal -5, because that's where the hole is at. But to figure out the y-coordinate of the hole, you would plug in -5 into the reduced form. What is 1 over -5 plus 1? negative 1/4. So your hole is at negative 5, negative 1/4. So if you have a hole, factor, cancel, plug the x coordinate back in. That will tell you where the graph would have been if you had no hole. Part A, horizontal and oblique asymptotes. What's the degree of the numerator? Denominator. So, yep. Y equals 0 is your horizontal asymptote. All right, let's graph it like we've never graphed before. So let's see. We don't have any x-intercepts. We have a y-intercept at 1. We have a vertical asymptote at negative 1. All right, so vertical asymptote at negative 1. We have a hole at negative 5, comma, negative 1/4. So it's like you're plotting a point, except you just put an open circle there. A hole. And then we have a horizontal asymptote at 0. Oh, there we go. The reason we do not need a calculator is because this graph is a transformation. Looking at the reduced form, 1 over x plus 1, you would take the graph of 1 over x and move it to the left 1. Yeah, I got you. So that's why we do not need a calculator. We should recognize this as a transformation. So, with that stated, it's going to start along this asymptote, hit that hole, skip over the hole, go along that asymptote. Start at this asymptote, go through the y-intercept, go along the other asymptote. I only want perfection, nothing much. So again, we just use a transformation of 1 over x, which is your reciprocal function. The only difference is it's moved left 1, and we have a hole in this graph at negative 5. Other than that, this is a nice problem. The previous one was not a nice one. Oh, wrong one. So I would not make you graph this one. It's too ugly. But this is good. I like it a lot.